Okay, welcome back everybody. This is the study hall for March 12th. We got some more word problems for you. We've just finished going over the rules. Here again, just a couple of reminders. Smiley face and other emotion icons are underneath your name. And this is the away button. Please use it if you are away. And here is where you find multiple choices. Underneath your name, you will see a letter A. You should see it now at least. And then you'll find the multiple choice answers in that area. And all of the problems are from the free GMAT prep software, copyright GMAC. Okay, let's go ahead and get started with a problem. How about this horrible looking thing? And remember where you find the answers to the problem. This is a data sufficiency, so we do assume that you're familiar with the multiple choice answers for data sufficiency. So there, we're not showing those. If anybody needs to see those, you can chat that, but we assume you're familiar with it. So give this a shot. Okay, at this point you should ask yourself whether you are still making real progress toward a real goal that is real. It's a long problem. There's no, it's a problem if it takes you longer than the average time to do this problem, but at all times you should be sure that you are actually doing something for a reason. Okay, let's take about 15 more seconds for you guys to answer this thing. Okay, let's talk about this thing. Most of you have either A, apple, or D, dog. So it seems like there's some general agreement that statement 1 is sufficient here. Like, what is the deal with this kind of thing, with this sort of problem where there are all these words going on? Like when you see something like this, what thoughts should you have? It's a very general question, but in which, if it took you almost a minute to understand it, it's actually pretty fast in big picture terms. So, I'm sure it took some people longer than that. But yeah, translating is going to be the issue, but also, because remember, this is a GMAT. This is a test full of problems that are basically short. That's the one thing that they have in common, is the problems on this test are not long. So what that means is that even when there are tons and tons of words in the problem, as there are here, there should still be some key to the problem that is relatively simple. And yeah, so the do things and don't not do things. Well, if you're reading with an intention of translating, that is doing something, but as long as you're making progress with it, right? But as we talked about before, this was the theme of the last couple of sessions where we talked about word problems. Remember that the thing that makes word problems annoying or hard is the fact that they are in paragraphs. And that's really all it is. So if you have trouble understanding what's going on here, the first favor that you can do yourself is to get this stuff out of the form of a paragraph. So it's okay. In other words, let's just pull stuff out of there, and then we'll see that it's not as complex as it might look. So they define this thing, average daily balance, to give you a definition of it. So therefore, it doesn't really matter that it's called that. They could call it pink flamingo if they wanted to. But ADB, let's call it. So this is basically just the mean of all 30 dollar amounts, mean of the dollar amounts for each of the 30 days. And if you're writing this with your handwriting, you're probably going to write fewer words than that, or you'll probably abbreviate that in some kind of way, but the point is there it is, right? And this is going to be the thing that we are ultimately trying to find in the problem too. Like the goal of the problem is to see whether that has a single value or multiple values. So it's the mean of all that. So remember to make connections if you can. What else is equivalent to finding this? Mean a bunch of numbers. Being able to find the mean is equivalent to being able to find what other thing? You can find, okay, that we're getting there in a second, but I mean, if you ever have to find an average of any numbers, then that's equivalent to finding the what of those, the total sum of all those numbers, right? So this is the same as, in data efficiency, it's literally exactly the same question. It's the same as what's the sum? Because it's just 30 times whatever that is. So, okay, so now let's just talk about what is going on here. So at the beginning, there's $600 in there. And then there's only one thing that happens to this account during the whole month, which is there's a $300 payment. So if you think about this, then you can think about what? You can split the days of the month up into two groups, which are you have the days before the payment, and then you have the days of and after the payment. Okay. So, well, you have days. We can organize this, right? You have a number of days. You have $1 per day. And so you have the sum. And then, all right, so let's say, because one of these things is an unknown here, the idea is, so whatever you make that payment. So if it's on day after day n, let's say the n days go by before you make that payment, then what's the balance on each of those days? It's going to be 600, right? So, okay, this is 600n. But then you have 30 days in the cycle, so the remaining days are what's left out of 30. So that's going to be $300, so she paid off $300. Okay, and so the sum is going to be 600n plus 9,000 minus 300n. And you know what? We don't even care about simplifying that any further because this is an expression that has n in it, and it's a linear expression. So the point now is we can realize that finding this is the sum. Finding that same as finding the ADB, which is the same as just finding n. So I know this is the same as I know n. Because if you have that, you can solve for n, and if you have n, you can just plug it in and you can find that. So it's a scary problem with lots and lots of words in it, but ultimately, at the end of the day, this is really just asking you what n is. Like, what is the day? Technically, the way I've done this is that n would be one less than the date of the payment. Because if you made the payment on the 21st, then this would be 20 days before that. But since it's data efficiency, it doesn't matter, right? So the first problem is telling you that n is 20. So this is definitely sufficient. What about statement 2? What if we did, let's go out with statement 2. Statement 2, okay, but why? The analysis for statement 2 is going to be pretty similar. Intuitively, you might be able to figure out, yeah, but I guess I'm not really talking to you if you really have that intuition, because that means you don't really need help with the problem. But what you can think about this, the thing that you can think about is, this is kind of the same analysis we've already done, except that you can put 25 in there. Because we're talking about the average balance through the 25th day. So it's kind of the same problem that we did before, which is, except the difference is that these are going to be slightly smaller numbers. But still, at the end of the day, you're still looking at, if I know n, then this is a thing that I also know. So, still a thing. So let's see, average is x and well, you can also think about it in terms of 2 letters like that, although that what we're doing here is probably more efficient because you don't have to worry about eliminating a variable. But that is a thing. You can also do that. Right, so if you know this, then you also know n, and this time they're telling you, you know this, which means you know n, which means you are good. Does it matter what this number is? Are you sure? Ah, because it could be 600. What happens if we make it 600? Because then we don't know. Because this would tell us that the payment was not made until after the 25th day, but there are still 5 different days where that could have happened. 26, 27, 28, 29, 30. So make sure you don't take anything for granted here. Like when you do this whole thought process, you still need to think about, okay, well, this is only valid arithmetic if the day is actually within the first 25. That would mean the balance would be less than 600. So this is, and so you're good. But if it were 600, then you would be looking at a totally different thing. And again, depending on how much intuition you have here, you might not have to calculate any of this. Because like if you think about this, you could just think about it in terms of, okay, well, I mean, again, if you had significant intuition about this problem, then this whole part of the lesson is not really aimed at you. But, I mean, you could, if you had the right kind of intuition. I mean, you could just say, okay, the earlier the payment was made, the lower the ADB. So it's going to be a function that goes down as the payment gets made earlier. So therefore, this is going to fix it somewhere. It's kind of like tax liability, like with the federal taxes. That goes up the more money you make. So if I give you any particular tax liability, you should be able to tell me the taxable income, and vice versa, right? So this should fix the value somewhere. And then when you think about the second statement, you can also think about then this is also a decreasing function of the n that we talked about on the previous page. So sure. Okay. But again, if you have that kind of intuition, then good. But just make sure that you vet it, make sure you think through the whole situation and make sure it's not more complicated than you think it is. Okay. Let's talk about another problem. So this one was D, like dog. They're both sufficient the way they were given. Let's try another one. About this one. Okay, I should be wrapping this one up here pretty soon. Okay, if you don't have a choice, you should probably pick a choice. Just go ahead and pick something. Let's take a look here. When you have a problem like this, the deal is these kinds of calculations are all, it's basically like doing a bunch of arithmetic. And it's all the type of arithmetic that you wouldn't really have too much trouble with in the real world. But still, a lot of these times these problems cause people trouble just because there's a lot of information. And again, the paragraphs are just not the greatest way to present this kind of information, right? So first, again, you want to talk about collecting the information from the problem, organizing it, then thinking about how to do the problem, right? So organize, get the information, then solve. So again, organizing doesn't have to be in a chart. And in the case of a problem like this, it probably shouldn't, because this is really just a chain of steps that you use to get from the beginning of the problem to the end. So let's just look what we have. So notice this first statement. The first statement is a statement about how much gasoline the car uses. So this is a thing. It's at a particular speed, but notice this is not anything about the speed per se. So you have to understand that much at least. This is just qualifying when the car gets that fuel economy, which you might want to peek and make sure the car is actually traveling at that speed, and it is. So that's not really relevant up there. It's not really helping us. So, but we have miles per gallon there. What do these kinds of units let us do? Like when you have this much every that much, whether it's gallons per mile or miles per gallon or miles per hour, like what do those units let us do? How do you use them? We use them to cancel out terms. You can think about it that way, but they are conversions right there. That's what you use rates for. So the green thing's up there, conversions. So you can use the first one to go from miles back and forth to gallons. If you have either one of those, then you can find the other one. And then also if you have miles, then you can go back and forth with hours using the second one. And then these are not rates, these two things. These are just numbers. So as far as organizing the process here, the deal is you can realize that you start with 5 hours. Then you can go from hours to miles because you know how to do that. Once you're in miles, what can you do? You can go from miles to gallons. Yeah. And then once you have this, finally, the amount of gasoline used, then you can divide this by the amount that represents a full tank. So, okay, so 5 hours is 5 hours. Remember how to use conversion factors. You, as Day 4 says, to combine, to cancel out like terms, right? So if you have a conversion factor here, then you're going to have hours on the bottom so that it cancels. So this is going to be 50 miles per 1 hour. And that kills this. And then the next conversion factor, what are we trying to, what units do we put where this time? Done using this one. Gallons go where? Gallons per mile, because gallons go on the top, and then we want to mathematically eliminate miles. So those there. So that's 1 gallon per every 30 miles. And so 5 times 50 over 30, same thing as 5 times 5 over 3. So 25 thirds of a gallon. That's how much you use. So then a full tank, this is not asking you how much gas you have left. We had a few people thinking B, like boy, which would actually be the remainder of the 12 gallons. It's just going to be that divided by 12. So the fraction that you want is 25 over 3 divided by 12, which is the same thing as 25 thirds times 1/12. So there you have it. It's 25 over 36. So again, just think about, you might have this chain of thinking in your head, but just make sure that you do that. And having it on paper can definitely help you do it faster. Because this problem is pretty efficient if you know what you're doing at each point. But a number of you got it right, but took a really long time to do it. So that would suggest some sort of role that could be played better by writing stuff down on the paper and looking at it with your eyes. But most of you got this right, so good. A couple of you guys appear to be typing questions. So I can wait and see what's going on there. So you did a division, 25 and 3. Well, okay. You'd want to be careful with estimating things, though, because this is really, really close to this. This would be 24 over 36, and this would be 25 over 36. So don't estimate stuff if things are that close. And also on top of that, your answer had a 25 in it, so that should be another reason to not get rid of that, because there's a 25 here. There's also a 25 there, but if you see the same numbers in the answers, that should be encouraging as far as keeping the numbers that you have. So in general, estimating is something you only want to do if you know it's not going to poke holes in your answer. Like if the answer choices are really super far apart, that's when estimating is a thing that is advisable, because in that case, the answers are super far apart, and there's no risk of going off the rails with an estimate as there is here. Okay, let's do another problem. What about this one? Okay, at this point, make sure you are still getting somewhere profitable with your work, if you're still doing work. Make sure you're doing it for a reason. Okay, let's talk about this thing. If you don't have an answer, you can probably pick one pretty soon. Okay. Did anybody have any reasonably strong intuitions about this problem, one way or the other? Notice what it is that we want. We want to find a percent increase in revenue. So percentage increase is what you want. So we think about what would give us this. If you have some advanced thoughts about that, I can streamline the process of the problem here. So if you had all of that information, then of course, yeah, but they're not going to write data sufficiency problems like this. Like if you, in other words, you have like specific numbers of units for both years and actual prices for both years. Yes, that would tell you that, but this is absolutely not how data sufficiency works. So in fact, if you ever found this much information in one of these problems, you can be pretty sure that your answer is wrong. Because it's probably one of those C trap things, because they just don't do that, right? And what they do in data sufficiency is they give you situations where there's incomplete information, but often enough to find the thing that you want to find. So the same thing, right? I mean, if they gave you exact numbers of revenues, then you would be good here too. P2, not really sure what P2 means, but if you think about what we would need to find in terms of growth, remember these are ratios, these are proportions. Like if we found price growth and we found sales growth, what kind of growth would we need to find? Like that's growth as measured how? Yeah, it's like what Romine is saying. Because the thing is, you would want price growth as a ratio or percentage. And you would likewise, you would want sales growth as a ratio or percentage. Because that's how you're going to figure out percent changes in revenue. It is both of those. Because I mean, if you think about it as price times, I think that might be what P times Q means there, Chris. If you think about price per unit price times number of sofas. I mean, if you have a percent increase in this and a percent increase in that, then you're going to have an overall percent increase, right? So, like, I mean, for example, if both of these, if both go up by, let's say, 30%, then this is going to be times 1.3, and so is this. So therefore, you're going to get revenue times 1.69. And so revenue is actually going to go up by 69%. That would just be an example. I mean, intuitively, this would be what you'd want, because the idea is that if you know percent changes, then they will tell you other percent changes as percents, and you don't have to really know anything about quantities. But notice that this is not a percent change. And so intuitively, what you might be thinking about this is, I don't know what this means as far as change. What is the relative magnitude of this change? I mean, those are big words, but meaning like if a sofa right now already costs like $2,000, and this is really not that much of a big deal. But if a sofa is $50, then of course this is a giant change. So intuitively, you might figure out that this is going to have an ambiguous meaning depending on how much the original price was. But we can organize it. If you're going to make a standard chart for this kind of thing, what would you put in the chart? Or what would be your headings? You get, yeah, price, right? Price per sofa. And then quantity of sofas. And then revenue, which is the product of this. Exactly. So if you multiply this by this, you get this. Now, ordinarily, we would make 2 copies of this chart because ordinarily with data sufficiency, you should always make 2 copies of everything that you make. But in this case, you might not, because it should be reasonably clear that the individual statements don't solve this thing. Because alone, I mean, nobody picked B. There were a few of you who picked A, though. So A is not sufficient because we don't know about price change. And you should be clued into that, because if you look at the other statement is talking about changing prices, so you know that that's an option that you have. So A is not sufficient because we don't know what happens to the price. And of course, statement 2 is not sufficient because we know nothing about quantity sold. I mean, we don't know if we even sold anything at that price. So therefore, we only need to worry too much about putting the statements together. And I mean, if it is clear enough that they're not sufficient, then you don't really need to make the second chart. Otherwise, go ahead and make the second chart. So here, we can just make this one chart for the 2 statements together. So this is going to be last year and this year. That's years typo. Okay. There it is. And what you want finally is another row that talks about percent change, because that's ultimately the goal. So from those 2 items that are there, that's the goal. Percent change. Okay. Well, let's try this. I mean, one way you can try to do it is algebraically. Do algebra. Then let's say that's P last year and number of sofas. I think my internet blipped there for a second. Okay. So if you had a P and an N, notice that ordinarily you should try not to define multiple variables, but in this case, it's kind of hard to avoid because there's no initial relationship between these 2 things. So your revenue is going to be the product of P and N. So then what, according to these statements, what is the new price per sofa? The new price per sofa is not, it's P plus $30. The 1.1 is what happens to the number of sofas, so that is going to be here. So then smiley face, if that makes sense. Smiley face icon. We're on board with that. Okay, so you're going to multiply those. So 1.1 NP plus 33N. And so the percent change here, we need to make this box a little bit bigger. That didn't work very well. The percent change is going to be technically it's the new minus old over the old, although you can also just do the new minus the over the old and subtract 100%. But if not, if you want to set it up the formal way, it's 1.1 NP plus 33N minus NP all over NP. So you can see what the deal is here. That leaves you with 0.1 NP plus 33N over NP. So the N goes away, but the P doesn't because it's not in the second term. So this is just 0.1 P plus 33 over P. So this is actually proof that it's not sufficient, although again, it doesn't really look like something that is a proof. It kind of just looks like we shoved a bunch of variables around and got nothing to happen. So, but it is a proof of the insufficiency. But what other way is there to approach these problems that is much better at showing insufficiency? What's the other approach that you have besides algebraic approaches? Yeah, you test cases, right? So for sure. I mean, you can intuitively you can see that this is a thing that gets bigger the smaller that P is. And that should make sense because if P is some tiny price, then this will be a much bigger change in the revenue. If these things were originally $1, then this is going to be, they're going to have 30, 40, 50 times as much revenue as they used to. So, but yeah, let's just test cases. So let's do that. Here's the chart that we made. And notice you can organize these problems without deciding on a strategy yet. That was one of the other main lessons from last time was you don't even need to think about how am I going to do this until you have it already organized and ready to go. So, I mean, I like to write everything down all the time. My memory is not very good, but even if you do have a good memory, don't make yourself remember stuff. Because like at least one person switched the 10% into 30 because probably not written down, right? So plus 30 is going to happen here. This is going to happen with adding 10%. Okay. So let's pick numbers. I mean, we can start with numbers like 10, 10. So then now it's 40 and 11. That's a massive percent change. It goes up by 330. So that's 330%. Okay, I mean, you could probably already tell that other numbers are going to be possible. I mean, 330% shouldn't seem like an answer that you're going to get every time. But which one of these, now this is where it helps to have an intuition about the problem. Like, which one of these things do we need to tweak? The price or the number? If you don't know, then you should just start tweaking them and just do stuff and don't not do stuff. But which one of these do we have to adjust? Yeah, the price is the thing that's important to adjust. This is where the intuition is helpful because it'll turn out, and you should experiment with this when you review these problems. You should try them from all angles, including this kind of thing. But if you tweak the number of sofas, then this will be the same. Like if you make this 20 and 22, this will still be 330%. And that's because percent growth is percent growth. So, but if we adjust the price, so let's make the price $100, and let's keep these the same. Now the price is $130. So this is going to be $1,000, and this is going to be about $1,400-ish. So we don't need to calculate the exact values because this is clearly not 330% increase. So still not sufficient. So E like elephant. Any questions about this? Notice that this time you can estimate because, again, as long as you can establish that this number is not 330% change, then you're fine. And this is pretty clearly not a 330% change. It's going to be 30%, 40%, 40. Yeah. Okay. Any questions? No questions. All right, let's do another problem. How about this? Okay, if your name's in the first half of the alphabet, for some reason very few of those people have answered the problem so far. But I should have an answer to this thing pretty soon. Also, if you've seen my previous study halls, there's answers here that are don't do it. So don't do it. If you don't know what I'm talking about, then we will get there. And remember, sure, a lot of these problems are on forums. They are free to distribute. So I'm sure a lot of these are on there somewhere. Okay. Let's pick something that is a thing. Okay, well, I don't usually show the class distribution, but I'll do it this time. Cause, yeah, so there's this answer choice right here. Here is what Drake has to say about that answer choice. Drake says, he says, don't do it. Don't do it, please don't do it. Yeah, let's have a little heart-to-heart about choice C here, and while we're at it, about choice E. So, if you pick choice C here, then, because they give you that statement about differences and stuff, so if you pick C, then, well, I have Jim's salary. I have Kate's salary. So I can just find Mary's salary. And then I'll have all three salaries. That's the reasoning behind choice C. So, yeah. Let's talk about that real quick. Let's talk about it in two ways. First way is this too easy? Yeah, I would say so. And I mean, too easy is kind of a subjective criterion, but if you don't have a sense of what too easy is, then go to the problems in the very beginning of the official guide and just look at them, because even those problems are not going to be anywhere near as easy as C would be here. Like C would be just like, okay, there's a $10,000 difference. So therefore, Mary makes $40,000 plus $10,000. I mean, that's much easier than anything that's even in the very, very beginning of the OG. So now let's ask the other question. Does it ignore stuff in the problem? Does it? Well, you bet it does. What does it ignore? Like, what do you not have to think about if you pick C, which is supposed to be the crux of the entire problem? What is the goal of the problem? Yeah, the goal of the problem is the arithmetic mean average. I mean, this is going to sound really obvious in these words, but if they ask you about the average, then you better have to think about the average. And in stronger terms, if you don't have to think about the average, you are definitely going to get this problem wrong. Yep. If you don't have to think about this, your answer is wrong. Period. End of story. Because that's the point. The point of data sufficiency is focus. Because it's this problem type, in case you've been wondering why did they invent this weirdo problem type called data sufficiency. Like, you're looking at one of the reasons right now, which is that they can punish people for finding too much stuff. Like here, you just have to find the average, and if you try to find all three items, then you're going to get soaked because that's not the problem. And again, in multiple choice problems, they can't do that. Like if you had a multiple choice problem and you were able to find all the salaries, then you win. Good for you. But you know, they can't test you on partial information like that. But here, they absolutely can. And so you really have to understand that this is the point the point of data sufficiency is to test focus. And like what the thing is here is, because if you get a multiple choice question wrong, then you probably made a mistake somewhere, which again probably doesn't sound like a genius observation. But if you get one of these problems wrong, you're probably not making a mistake. You're probably just solving the wrong problem right from the start. Like if you see this problem, if you think I need to find all the salaries, then you're already wrong. You're wrong before your pen even touches the paper. You're like pre-order wrong before it's even in stores. Already wrong. You should anticipate the way that they're going to do this. Like a couple other problems, if they say, what's the tens digit of some number? If you think I need to find the number, you're going to get the problem wrong. You should expect to find the tens digit of the number and not find the number. That's how it works. What is x plus y? You should expect to not find the individual values of x and y. You should expect to find the sum. And you're going to get it wrong if you try to find the individual values, etc. Because again, this is something they can only do in data efficiency. They cannot make this happen in a multiple choice question. So, yeah. In summary, C traps, the ones Drake's telling you don't do it. If answer C does both of those things that we've listed above, if answer C is too easy. And again, remember, you can judge way too easy by looking at the beginning of the official guide and seeing what the bottom threshold is for these problems. Anything that's much easier. In general, if you're just doing arithmetic, then you're in trouble. And ignores things in the problem, especially the goal of the problem, then don't do it. Because it's going to be wrong. Then don't do it. And so, yeah, you don't want to pick C. What else do you not want to pick in these situations either? Look at a couple of these. Yeah, don't pick E. Because think about what choice E means. Choice E would mean that even if you have both statements, it's still not sufficient. But guys, what? Like the point of C-trap problems is that it's super obvious that it's sufficient if you do combine the statements, because you find like all the things with no effort. So if you pick E would imply here that even if I had all three salaries, I still couldn't find the mean salary, but that would be ridiculous. Of course I could. I would have all the information. So notice we're eliminating it for different reasons. Like C is a trap answer. It's not an unreasonable answer at all. In fact, the reason why it's tempting is because it's so reasonable. Whereas E is an answer that is logically impossible right from the get-go. I mean, if you have all of this information, of course you're going to be able to solve the problem. So, C-trap, don't do it. Let me show you my favorite one of these things from, this is probably the official guide, but I've also seen it in the GMAT prep software, which means that I can reproduce it here. So I put it on the board. It's like my favoriteest trap problem ever. No, favoritist is not really a word, but now it is. Okay. This problem is just lovely. Like, we're not going to do this problem right now. We're just going to talk about why you want to not pick choice C or choice E. So, again, this is my most darling, most favorite C-trap problem ever. Because, yeah, I think about picking C here. You pick C here. This is great, right? If you pick C, you're adding 1 and 4 and getting 5. Like, what? So, too easy? 1 plus 4 is 5. I'd say so. So, yes, this is way too easy. Check mark. Does it ignore stuff? Well, you darn well bet it does. I mean, yeah, right. If you're picking C to this problem, then you are basically saying I could ignore like all the things north of that bottom line. Like, I don't care about the circle, I don't care about the other line, I don't care about the triangle, I don't care about Q, I don't care about the 2. Like, yeah, that's not going to work like that, guys. Like, here you're basically ignoring everything. Like, you're pretty much ignoring the whole diagram. So, that's not going to happen. This is definitely don't do it. Again, for the question in the chat box, remember how, again, too easy here means like easier than anything that's in the entire official guide. I mean, no matter how badly you're doing in quant, you're not going to be adding 1 and 4 in a problem. It's not a thing. Also, it's a bad idea to try to make judgments like that at all because you won't know. I mean, in fact, almost everybody who has done really well in the quant, in debriefing, like after they take the test, they all thought they did terrible on the quant while they were taking it. And because that's, you know, ironically, that's a pretty strong indicator that you're getting challenging problems. So like, if you think it's just a, you know, trip through hell, then you're probably doing pretty well on it. So yeah, don't pick C, don't pick E. Don't do it. I mean, because also think about what E would mean on this problem. Like, E on this problem would actually mean even if you gave me 4 and 1, I would not know this was 5. Because, you know, some people will OC trap, so I'm just going to guess any other answer, and I would guess E, because it's like, it's just a letter, that's not C. But make sure you don't do that, because, yeah, if you had 1 and 4, that would be sufficient. Okay, let's take this and let's take a look at this, knowing that, yeah, don't pick C and don't pick E. B, because don't do it. All right. Let's talk about this thing. So the difference between Mary's and Jim's annual salaries is, so this problem, the one annoying thing in this problem is they give you these facts in the order that is opposite the order in which they are useful. Because if you don't have this orange statement yet, then actually that blue statement is an annoying thing that involves absolute values. Because, you know, the difference in Mary's and Jim's annual salaries would be like the absolute value of one of them minus the other one. But, because we wouldn't know which one was bigger. But then they tell you Mary's is the highest. So that gives new meaning to this blue statement. So one takeaway that you should get from this problem is that you should not be afraid to read the problem more than one time. Especially when there's new things in play. So, meaning especially if the statements have new interpretations, new or more specific interpretations. Because, you know, like that blue thing when you first read it is like, oh my gosh, absolute values. What did I do to deserve this? What did I do wrong in previous life? But then you get to that orange statement and it's like, oh, hey, I know that M is the biggest one, right? So then you can go back and reinterpret the blue statement. There's no more absolute value nonsense. So difference between Mary's and Jim's, and that's going to be 2 times the difference between Mary and Kate. And we know that these are subtractions where m is the top of the subtraction. It's m minus j equals 2 times m minus k. Now, what is the goal of the problem? Yeah, okay. The goal of the problem is that. And because it is data sufficiency, you don't really care about the over 3 part. Because that's incidental. I mean, if we find that, then we can always divide it by 3. So the goal of the problem is really to find this. And so you should manipulate this with that goal in mind, meaning you don't do random operations on these numbers. You should think about how I'm going to get that. So here is a k. There is actually 2 k's there. Let's distribute that. M minus j is 2m minus 2k. So you can think, okay, I can probably get all of that on one side of the equation, maybe. So maybe I can. Well, let's simplify. We can get that m out of there. Subtract m from both sides. All right, I can move j to that side. And then I want plus k. So I'm going to do something that would be inexplicable if you didn't really know that I had that as my goal. But if I do have that as my goal, it's a step that makes perfect sense, which is I'm going to add 3k to both sides. So, because now that gives me the average over there, or at least the sum. Ah, look at that. Okay. So this shows me that my goal is actually just this. This is not the only way to do this. Well, we'll see in a sec. But what we've discovered here through purposeful, this is not an accident. Like we slid things around until we had m plus j plus k on one side. So the goal is the goal can be accomplished by finding k. So that means it's going to be B-boy, because I mean statement 1 doesn't give you K. Statement 2 does. So we can do that. That's an algebraic approach. The biggest takeaway here is, again, this step. Like, make sure you know what the goal of the problem is, because this seems like a weird step. But when you know what you're trying to do, then it's not a big deal at all. And what Respina has there is equivalent. Another way of doing that, like a substitution. Okay, my internet is being stupid again. All right, let's talk about how else you could do that. Let's take some of this to the next screen. I don't know that we're going to have time for another problem, but maybe we'll see. No, that didn't work out very well. Okay, that is what we have. Another way that you can do this is you can think about it visually. Like if you don't know what to do with this algebraically, data sufficiency grid. I think what you're talking about is something that we use when data sufficiency is brand new to people. Like that's, because the thing that you're talking about is something that you honestly shouldn't really have to use after the first few weeks of studying data sufficiency. It's really just a reminder of what the choices mean and don't mean. So the idea is to be able to dispense with that after a little while, at least if you're talking about the ADBC thing. Oh, God. Another way you can approach this thing is visual. You can think visually about it. Let's try that. What does this look like on a number line? If we put these salaries on a number line, what is that? How are they arranged? On the number line. Okay, they're going to be to the left of M. Here's M. M is on furthest to the right for sure because it's the biggest. And then how are the other ones spaced out? Think about these differences. Yeah, J is going to be in the middle, and it's more specific than that, though. That is the spacing. But think about these. Like, you're going to have a difference, and then you're going to have another difference, which is exactly twice as much as that one. So if you think about how these are going to be placed, this is going to be Jim. And then think about where we're going to be putting Kate. Sorry, that's Kate. What's the difference between, okay, I wrote that statement backwards, that's why. This is supposed to be a K here. And this is supposed to be a J. Yeah, okay. And then J's over there. And then notice, how are they spaced? Well, they are spaced exactly equally. So remember, the goal is an average. If you think about how these things are arranged, where are you going to find the average? Yeah, it's going to be a midpoint value, exactly, or equally spaced. So the average is going to be the same thing as the number in the middle. Absolutely. So then you know the average is going to be K. That's supposed to say K, not N. And it's going to be B again, like boy. The last thing you could do here is you could totally just test cases, right? You could use this equation, and you could test cases with it. So let's just do that, and that'll take us pretty much up to the ending time. Here's a problem again. Here's the equation that we figured out. So you can just make a table, Jim, Kate, Mary. And then for the two statements, remember the goal is to try to get two different numbers in there. So for statement 1, you have to pick 30,000 for J. Let's just put 30, so we don't need to keep putting the OOO there. So, well, if M is, let's say, 50, then M minus J is 20. So that means that that would have to be 10, and so K would have to be 40. And then the average is 40. So what's our only goal in life at this point? Well, to get a different value there, right? So one way to do that would just be to make M minus J some huge, huge difference. So if this was like 1,030, now this is 1,000, and this is going to be 500. So, well, that average is certainly a lot more than 40. So not sufficient. At this point, if you know that C is don't do it, then you know this is going to work out to be B. You just know it, because it's definitely not going to be C or E. So, but you can still work that out. So this is going to have to be 40 in every case that you test. So now what we're going to be doing is M, you can find M again. And then you can use that statement about differences. So if you let M be, you can recycle that first case. It's always better to reuse information. So we can still have 30, 40, 50. So always recycle cases when you can. But then we just pick another value and just start seeing what happens. So get that in there. If we try like 60 for Mary, then that's going to be M minus K is 20, so this would have to be 40, so this would have to be 20. Oh, hey, the average is still 40. I think I see what's happening. If this is 80, then Jim must be an unpaid intern, and so this is still 40, etc. You're always going to get 40. So that's sufficient. That's what sufficient looks like when you test cases. It looks like I'm getting the same thing over and over again forever. So, you could get a lot of different scores. There could be many possibilities for that. Okay. Let's kill this. Thank you guys for attending. And we're probably going to do something in verbal next time. Although that depends. It's always a decision I make at the last minute. So, let's see. All right. Time to kill the recording. Good night, good afternoon, good morning, good luck. Thank you. And see you next time.